Okay, good afternoon everyone. Welcome. My name is Sree Sreenivasan. I'm Columbia's Chief Digital Officer, and it's a pleasure to be back in beautiful Butler Library for this conversation about higher education. This is part of a series of conversations we're hosting with CCNMTL, the Columbia Center for New Media, Teaching and Learning, to talk about teaching and learning. And what we love about this is that it brings out people from all over campus to talk about talk about education, about the university, and where things are going. In this series, we've already had presentations by Daphne Kohler of Coursera and Jeff Solingo, the Chronicle of Higher Education, who has a new book out called College Unbound. Today, you're going to hear from Candace Thille, who is the director of the Open Learning Initiative at Carnegie Mellon. Before I introduce her, I just want to remind you that you can use Twitter to kind of keep track of our conversation here. The Twitter handle is #CUThille, Thille, and her Twitter handle that we're using for the initiative uses is at CMUOLI, and you can also, of course, use CCNMTL as well. And we would love your feedback about this series. And by the way, you can catch all of these on YouTube. Just search for CCNMTL and you'll find the series recorded there. And we hope to have many more such conversations in the weeks and months ahead, even during the summer. We have Anant Agarwal, who's going to be joining us from edX, as well as others. A group of folks suggested we get some skeptics in here, Candace. So we're going to do that as well. So nominees for skeptics are most welcome. And I don't know what they're skeptical about. On my Twitter bio, it says I'm an evangelist and a skeptic. So I think that's the right way to be. So let me tell you a little bit about Candace. But I want to tell you what the opening line of a Chronicle piece about her said. "Oh my God, she's trying to replace me with a computer." That's what some professors think when they hear Candace pitch the online education experiment she directs, the Open Learning Initiative at Carnegie Mellon University. They're wrong, but what her project does replace is the traditional system of building and delivering introductory college courses. So you're going to hear about that from her. She is the director of the initiative, as you heard, and she has been running the program since its inception in 2002. And her focus is on applying the results from research in the science of learning to the design and evaluation of open web learning environments. And that's one of the things we're trying to do here is we're going to do a bunch of experiments, and then we're going to use the data and learn all kinds of interesting things. Candace is involved in many important projects. The Global Executive Advisory Board for HP's Catalyst Initiative. She serves on the working group of the U.S. Department of Education to co-author the National Education Technology Plan, as well as serving on the President's Council of Advisors on Science and Technology, PCAST, in which she's helped write the Engage to Excel report for the Obama administration on improving STEM in higher education. She's managed at a very busy time for her to come and spend the day with us on campus, has had multiple conversations. She's going to have another meeting right after this, but she also managed to turn in a report in the middle of all this. So it's been amazing. Please welcome Candace Thille.
So I also like this to be sort of a conversation. So I prepared some slides to give you an overview of what the Open Learning Initiative is, but I invite you at any point in time to stop me, interrupt, say, ask a question, make a comment, and get a sort of lively conversation going. But I'll start off by saying, what is the Open Learning Initiative? So we say they're open online learning environments that are based on the science of learning, and they're designed to improve both quality and productivity in higher education. Now, when I say the science of learning, that's an emerging field of interdisciplinary field that often has cognitive psychologists, sociologists, anthropologists, human-computer interaction experts, software engineers, lots of people who are bringing their expertise together in an attempt to understand human learning. So we take some of the things out of the science of learning and use the principles that we extract from the research to inform the design of the environments we build. So I'll give you an example. One of the things we know from years of research is that students learn when they are engaged in activity, not more so than when they're just passively sitting listening. So we put a lot of energy into thinking about how do we engage students in activities and give them context-specific, targeted feedback during the activity so that they can refine their performance. So I'll give you a small example out of one of our courses. This is out of our engineering statics course. It's a second-year engineering course. How many engineers? All right. That's 2 more than I usually have. All the engineers will know this instantly, but some of you may remember this from your undergraduate days. We give the students a simple task, which is 3 vectors, and we ask them what's the direction and the magnitude of the sum. So we simply ask them those questions. They can just type into the little box their answer. The system immediately lets them know whether what they've typed in is correct or not. If they're not sure what to do, they can ask for that little hint up there. And the system will give them a little text-based hint that reminds them of what it is they're supposed to do. And in this particular case, this activity comes at a point in the course, which is what we call a did I get this? This is after the students have undergone some learning activities when we would expect that they would know how to sum these vectors. So we remind them, at this point, you're supposed to be trying to see if you can work it out, but if you need some help, let us know and we'll give you that help. If the student clicks that, then the system will expand the tutor and say, remember, the first step is to resolve each of the forces into its components. Okay, so now go ahead and do that. So take the first force and resolve it. They're still not sure, they can ask for another hint. And the system will then give them hints and feedback for that particular sub-step. So I'll kind of fast forward through. It kind of reminds them how they're supposed to do it until it gets to what we call the bottom-out hint, which some of you would call the answer. So in that particular thing, it's 7.49. So the student can just type that in and go to the next one. And they can keep working through the problem, asking for hints and feedback as they go along. And so finally, I won't walk you through how to do this whole activity, but I fast forward it to where the student can finally answer the question. But the system says, great that you can do that, but we really would have expected you to be able to do this on your own. Would you like to try another problem? And if the student says yes, then the system will generate a new problem. All the hints and feedback change to target that specific task. So you can see what this provides the student is sort of 24/7 support in building fluency around how to sum vectors. And that is built on work that we've been doing at Carnegie Mellon for the last 15 to 20 years in the area of cognitive tutors. And what cognitive tutors are, they're pieces of software that are designed to act like a good human tutor. They watch the student when the student's working. When they're always there the student can ask for help. They sort of intervene and give feedback when the student needs feedback. Otherwise, they just sort of sit back. Now, you might be saying, okay, that's great, but especially at an institution like Columbia, we want students to develop more than just procedural fluency in things like summing vectors. Higher education is more than that. We want them not only to learn all these skills, we want them to be able to synthesize and apply them in novel contexts, create new knowledge. So we have other kinds of activities besides just these tutoring activities. For example, in our chemistry course, when we're teaching students stoichiometry, okay, how many chemists? Oh. Okay, well, so when we teach students stoichiometry, does anyone remember from your chemistry days what stoichiometry is? What's stoichiometry?
It's the balancing out of chemical equations.
Very good. So, it's the sort of mathematical, computational part of chemistry that you do in your first year of freshman chemistry. Students at Carnegie Mellon are great at solving dimensional analysis equations because it's kind of math. But what we watched students doing was we give them these problems, these paper and pencil homework problems. They would be able to do the calculation, and the way they often did that is they would look at the equation we gave them to solve. They'd take their textbook. They'd know, okay, we're in chapter 3 this week. I'll flip through chapter 3 until I find an equation that kind of looks like the one on my homework. I'll look at how that is solved. I'll plug the values from my equation into that procedure, solve the equation, get an A, have absolutely no idea how that equation maps to the chemistry or how that chemistry maps to the real world. So one of our goals in building this stoichiometry unit was to break that means-ends analysis approach and really sort of push students into that these are tools that you're learning to solve real-world problems from the perspective of a chemist. So when we teach them stoichiometry, we start them off saying, not, here's stoichiometry, memorize all these procedures. We give them a real-world problem, which is the arsenic contamination of the water supply in Bangladesh. And they get a little short documentary that explains the problem. It's a real-world problem. And then they get put in the role of chemist. And they get given this well water sample, a virtual sample, in this virtual lab. And they're asked a simple question. Is the arsenic level in this well water sample safe to drink? And they're told that the World Health Organization says that 10 micrograms per liter is safe drinking water. So they can analyze it in the lab and answer the question, is that safe? Now, if you look at this, no place on that viewer does it tell me how many micrograms per liter of arsenic are in that solution. It tells me how many moles of arsenic are in solution. So in order to even answer that first question, I have to be able to use the tools of stoichiometry and do that analysis. So again, they can just do the analysis on paper and pencil and type it in, and they'll get immediate feedback. They can ask for hints and so on like that, just like you saw before. But if it's really clear, they have no idea what they're doing, then they can do a just-in-time learning experience, which actually walks them through how to do the dimensional analysis. And then once they move past that part of the scenario, then they get given a sample filter that's made out of local clays. This is a solution that was done by a local Bangladeshi chemist, where he figured out how to use local clays to filter out arsenic. But then, since it's a natural substance, the absorption capacity of the clay varies, so they have to analyze, given the absorptive capacity of that clay, how often would a family of 4 who's drinking that level of arsenic in water have to change their filter to keep their water safe? And that requires them, again, to bring to bear a bunch more skills in stoichiometry. And this gets to one of my first points that I want to make, which is this notion of giving students feedback to change their performance. So what we're giving students is, instead of having them work through stuff and a month later, a week later, however long ago, give them the feedback, they get the feedback right at the moment they're trying to solve the problem, so they can use that feedback to refine their performance. Now, what you don't notice is, as the students are working through that environment, they're getting that immediate feedback, but there's something else that's happening. Every move that the student makes, every time they pour something from a beaker, type an answer in, ask for a hint, we're collecting that data. And we're collecting that data in a semantically meaningful way, so that we can give that feedback not just to the learner, but to the other actors in the education system. And one of those actors is the guy at the top, the instructor. So as a student, and then this is kind of the flipped classroom idea, but on steroids. Because rather than just having the students do lectures outside of class, we have them engage in learning activities outside of class. So both it's improving their learning experience, but also it allows us to collect data to give to the faculty member, so he or she has much better insight into their class's knowledge state before they start class. So what does that look like? So rather than, how many of you are currently teaching classes? Okay, a couple of you. So rather than giving your students, something to read outside of class or a lecture to watch online outside of class, you would say, if we teach Mondays and Wednesdays, and let's say it's Wednesday, I would say work through Module 3 of the OLI course and finish it before 10 o'clock Sunday night, because we're going to meet at 10 o'clock Monday morning. So all your students are working through the material, they're getting the hints and feedback, they're doing all their activities, and the system is collecting all that data to present to you what we call the Instructor Dashboard. Now, this is a project that was led by one of the cognitive scientists at Carnegie Mellon by the name of Dr. Marshall Lovett, who also happens to be the head of our Center of Teaching Excellence, as well as a member of our faculty in psychology. And so put together how all this data that we're collecting, how do we present that to faculty in ways that are actionable? So this is a snapshot out of an actual statistics course, not at Carnegie Mellon, this is at another institution. But what you can see is at the first screen, what you see are the learning outcomes for this chapter, for this module. So if a faculty member only has a quick amount of time, they can just look at this module and see the bar on the left represents their class. So the students that are in green, what we would predict is those students, if you were to give them some kind of task or assessment today, on that outcome, they would nail it. The students that are in orange, we would say those students are moderate. They're doing okay, they still don't quite get it. And the students in red, those students are working, but they are totally not getting it. Now, has anybody got an idea what the students in gray, what that means? Yeah, they haven't done enough work in the system for us to make any kind of reliable prediction. So then the instructor can go ahead and click in any of those bars and expand that information if they've got a little more time. So one way they might want to expand it is to say, for that outcome, and I've picked relate the measures of center and spread to the shape of a distribution and choose the appropriate measure in different contexts. That's the outcome. And there are a couple sub-skills that the students would have to be able to do in order to be able to achieve that outcome. So we can also see the distribution of the class on those sub-skills. I can also say, okay, so I got the nice bar, who are the students? So when I click on the bar, I can also see the distribution. Each dot in that case is 2 students in this particular class. So then I can go further and I can click on that little dot pattern and say, okay, who are those students? Now, because this is an actual class, and I'm trying to respect privacy laws, I did remove the students' names. But if you were the actual instructor, listed there where it says students' names removed would be the actual names of the students. And it also tells you how many activities they've attempted in this module that's driving that particular prediction on that subskill. I could also click in further on any of those students' names and see the view for just that student. So for that student, I can see on those first 4 outcomes, the first 3 outcomes, they're green. They're predicting they do really well. On this one, they were in orange, and these are the activities that they have yet worked on or not worked on. And then I can click on those and get further information. So that brings me to my question to you. So given what we can do with this technology, what are the affordances of how can online really help these kinds of, both not just online courses, but residential colleges? And when you ask most people, what's the great thing about online technology? They'll usually tell you one of 3 things. First one, which is what the MOOCs really leverage, is access and convenience. We're putting these things online. Students can learn anytime, any place. Access and convenience is probably the first thing people will say about online technology. The second thing I tried to imply is all that really cool simulation stuff you can do with computers that you can actually create more interesting learning activities than you can when you're tied to the sort of carbon-based world. I mean, you can have students build bridges and collapse them and nobody gets killed. So there's lots of really cool simulation stuff you can do. And then the third one, what I meant by that was connection. You can connect students to each other. You can connect students to other experts. You can connect students to the world. And those are the 3 big things people will say is the power of this technology: the access, the simulation, and the connection. And I think those 3 things are really critical and are really important. But I actually don't think they're the biggest power of this technology. I would submit to you that the biggest power of this technology is what Google has already figured out. It's what Netflix has figured out. It's what Amazon has figured out. The biggest power of this technology is not using it to push things out, but just to push it out just far enough into the interface that we can make them act like great big data collectors. And that's what we kind of think of as our killer app. It's this data collection for continuous improvement in higher education. And I already showed you the 2, so we take the same pile of learning data we're collecting, and what's a little different than the data that we're collecting than the data that most of the MOOCs and the other online environments collect is that as we're collecting the data, we are semantically tagging it in meaningful ways. So it's not just a massive click stream. It's a click stream that has meaning so that we can process it in ways that give us much more rapid information and insight into how to improve the environment and improve our understanding of learning. So in addition to giving the data to the feedback to the student and to the instructor, we also give the feedback to 2 other groups. One of them is to the course design team. As I think I mentioned, when we design an OLI course, we do not start by going to an individual faculty member and saying, gee, can we put your course online? What we do instead is we say we're going to create an introductory statistics course, and we bring together multiple faculty in statistics along with a bunch of other people, learning science researchers, software engineers, human-computer interaction experts, folks that know about universal designs for learning, and we bring them together in a team and together create the online environment. Then the first instance of the course is developed, and we have other groups of faculty, what we call review and contribute faculty, who are faculty that maybe don't have the time or energy or desire to be on a core development team, but want to be involved in the design. So they can sort of review the learning outcomes, review the basic approach, contribute 1 or 2 activities of things that they've tried that they think would be good. And then we also have the biggest group of faculty who we call our use and evaluate faculty. And they're still part of the development and research team. What they're doing is using the environments that we're creating with their students in their classrooms, and we're collecting their data and their students' data to refine the environment. And we also interview them and get feedback from them about what's working and not working to support their students. And so the better insight, we know that in the past we've done a really careful cognitive task analysis when we go to design these environments. And we know that doing that, both in our project and many other projects that use that approach, you can actually get much better results, much better design courses. But the new opportunity with this data collection is we can use the data to do some of this careful task analysis. Because doing a cognitive task analysis is extremely labor intensive. And so we can now sort of partially tag the data and then use the data to refine our underlying knowledge models. Well, this probably won't make a lot of sense to you. I will, let me see if I've got the others. No, I'm not going to do that one. So I can, if you're interested, what these basic graphs that that I'm showing there are, is remember how students could do hint, 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 or get feedback? Was there anybody that was a little worried that what a student was going to do is go hint, 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 get the answer, type it in. Hint, 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 get the answer, type it in. Yeah, okay. So the difference is that we know it when students do that. So these graphs are made out of the data that's being thrown off by the course. The y-axis is what we call the error rate or the assessment score. That's the number of hints and feedback that the student needed to have before they could actually successfully complete that task, that knowledge component. The x-axis is the number of opportunities they had to demonstrate that knowledge component in a number of tasks throughout the course. So those curves up, those top 2 curves, so those are actually 3 curves there, are the kind we like to see, because you can see that at the very beginning when the student was first confronted with a knowledge component, they needed a lot of support, and over time, it's sloping downwards. Now, this one, the flat learning curve, that's what we call a discovery opportunity, because the knowledge model is not behaving in the way we would have predicted. So that can either mean that we need to redesign the course, the activities that support that knowledge in the course, or that the knowledge model that's driving those activities is flawed, that something that we thought was a single concept is actually a conflation of 2 concepts. And we're fortunate enough at my project to have a sister project at Carnegie Mellon, which is called the Pittsburgh Science of Learning Center. And that's an NSF-funded learning research center. Their whole purpose is to define and refine theories of human learning. So we have this nice synergistic relationship because they use the OLI courses as their research lab. so they can introduce different experiments into the courses to refine their understanding of learning. And they also develop a bunch of these data analysis tools like the ones I was showing you so that we can understand what's going on in the courses. And we also do have a lot of results from our courses. The two that I will just point out, one was a recent study that was done by the Ithaca Foundation under the direction of Bill Bowen. And what they did was taking our introductory statistics course, there were 3 state institutions that did randomized controlled studies looking at the OLI statistics course against traditional instruction, and they were able to show that students did as well or better in the OLI version as in the traditional version with much fewer contact hours. And then the accelerated study, which we did at Carnegie Mellon and replicated a couple times, where we were able to show that students using the OLI statistics course with an instructor were able to complete this and achieve the same learning outcomes as students in the traditional course. But rather than meeting for 15 weeks, they only met for 8 weeks. And rather than meeting 4 times a week, they only met for twice a week. So it's actually, we always say half the time, but it's actually, in terms of total contact hours, a quarter of the time. And they did as well or better than the students in the traditional instruction. And these are both published studies if you want to read them. Happy to answer questions about the methodology on them as well. But this brings me to my actual point, which is this is my strategy for how we're going to improve higher education, which is we can use the education technology to collect data that we need to refine our theories of human learning. And then we use our theories of human learning to refine the design of the education and technology. And then we use the technology to collect data to refine our theories, and we set up this virtuous cycle of continuous improvement. And so I will just, this is my little closing thing, that we've already shown that we can improve assessment, we can increase outcomes, we can accelerate learning, and we can set up this virtuous cycle for continuous improvement. And I will just close with, oh no, first before I close, I have to say who funds me. So OLI is generously supported by the William and Flora Hewlett Foundation, the Bill and Melinda Gates Foundation, the Spencer Foundation, the Kresge Foundation, the Walter S. Johnson Foundation, the Lumina Foundation, and Carnegie Mellon University, and the Pittsburgh Science and Learning Center is funded by NSF. And I will close with a quote from Herb Simon, who was a Nobel laureate at Carnegie Mellon and a professor. And he said this almost 20 years ago. He said, improvement in post-secondary education will require converting teaching from a solo sport to a community-based research activity. And that is what we are attempting to create in OLI. And I invite anyone who's interested to join us. Thank you. And now, I will take questions.
Let's take some questions from the audience.
And I like contentious questions.
Only contentious questions.
Yeah, you can ask them. Yeah.
I don't know if this is contentious, but I get to see presentations that actually uses a humanities course. So I'm wondering to what extent you use humanities participates, and if so, what does it look like?
Okay.
Can you just repeat the question for the microphone?
So it's not a contentious question, but it's one that gets asked every time, so I should change my presentation. Do you think I'd take that feedback?
So the question is, basically, can you do this for humanities, and what does that look like? So we are currently working on the English 1 course, and the prime institution on that development project is Ole Miss, the University of Mississippi, and we have about 7 other institutions that are participating in that. And we're also just starting a global histories course at Carnegie Mellon. And we've done French, we've done speech for drama, out of our drama school. My goal was to have a class out of every college. So we have speech out of our drama school. And we have some language classes, French. But I think the question actually has 2 parts. Or I'll answer it in 2 parts. One of them is, it seems I get how you could do this, how these technologies are really useful for building procedural fluency. So if there's something that's got a right answer and you just need students to practice and practice and practice till they can get the right answer, I get it. Computers are great for that. But for more open-ended problems, for the kinds of things where you want students to engage in what we think of more as higher education, how can you really use a computer to do that? That's kind of what's, I think, at the source of the question. And I'm going to answer that actually in two parts. One of them is that if you ask, I mean, we have engineering faculty here, if we had chemistry faculty here, if you asked them, is the only thing you really want your students to be able to do is procedural fluency, would you be satisfied? And most faculty, and I don't care what discipline you're teaching, would say no. You know, that's not what I want. That's a minimum, but they need more than that. And in fact, I had a chemistry faculty say to me, no, Candace, what I really want is I want my students to be able to authentically participate in the discourse of the domain of chemistry. And I thought, wait, you're chemistry faculty? It sounded like poetry. But the idea is that what you really want your students to do is gain a perspective, so that when they're confronted with some kind of challenge, they can see that challenge through the eyes of the expertise of that domain and apply the perspective and tools and concepts of that domain to addressing that challenge. And we try and build that sort of support for that kind of conceptual approach in the courses as well. And I would also say that, back to how you opened my introduction, we're not trying to replace faculty with computers. What we're trying to do is look at how do we create an effective educational experience. And the resources we can bring to bear in creating that experience are what a student can do with a computer, what a student can do with their peers, what a student can do with an expert, with a faculty member. And how do we balance the distribution of the kinds of things we have a student do across each of those resources in ways that uses each of those resources to its best? And one of the things that kind of makes me sad is to the degree to which we're not really leveraging the expertise of our faculty, because they have to spend so much of the class time doing actually what a computer could do really well. And so that's part of the moving into the instructor feedback area, is give the instructor information about the student's knowledge state so they can spend that class time having much richer, more robust conversations with the student that really leverages their expertise. But that being said, yes, we are doing English and other courses, but they're not all going to be tutoring environments. That's the other thing is, we started off with sort of this tutoring approach because that's where we have the depth of expertise at Carnegie Mellon. But there's lots of different ways to use the technology to facilitate other things than just tutoring mechanisms. And I'll be happy to tell you some of the things that we're doing in the English course that are kind of interesting in that way. But the design approach is the same, of bringing together multiple experts to think about how do we create an effective learning experience for the students, and starting off thinking about what is it we want students to get out of it, and then how can we use the technology to design that. So I think you were next, and then I'll go there.
So you briefly touched on some
Briefly.
studies that you've done, where you were able to repeat some of these outcomes. I was curious if you did those studies with different courses, or if you only used one particular type of course, and were you able to achieve the same type of results across a breadth of different types of courses? And then also if you did any studies that compare an accelerated course to an accelerated course with and without OLI.
Okay, so I'll see if I can repeat all that. So he was asking about the studies, asking if we've repeated the studies with different courses or if they're all on the same course, asking if we've done the studies in accelerated with OLI, accelerated without OLI. Okay, so we've done a bunch of different studies. And so we've done the accelerated study and the, I guess the do no harm study is what I'd call the first set of studies, where we're just seeing students using OLI with fewer, over the same period of time, but fewer contact hours in a week, like 1 contact hour versus 4 over 15 weeks. I call those do no harm studies. So we've done the do no harm studies and the accelerated learning studies over multiple courses. Mostly statistics, logic, causal reasoning, chemistry, biology, and we've done some A/B studies too. So we're using the same group of students and changing their condition at different parts of the semester. So multiple different study designs looking at efficacy. The question of have we done an accelerated study of students not using OLI, just giving them an accelerated task, but not giving them OLI, just giving them the same thing? No, we haven't done that. And I guess the reason for doing that would be to see, is it could students accelerate anyway? Is there anything about the OLI that helps them accelerate? So that would be an interesting question. What we did do in the accelerated study, just so you know in terms of the study design, is my IRB would not let me just take the roster from Carnegie Mellon Intro Stat for next semester and randomly assign. So what I did do is I sent an email out to the students a month ahead of class, because I had the roster, and said, we're doing an experiment to do this accelerated learning study. If you want to participate in this study, go fill out this demographic survey. And then of the students who volunteered to participate in the study, we randomly assigned them. So we actually had two control conditions. We had the students who just were enrolled in the class and didn't volunteer, and we had the students who volunteered for the study and were randomly assigned to the control condition. And so there was no significant difference between the two control conditions. And we did replicate that study 3 times with different class sizes and different faculty.
If they didn't agree to participate in the study, how did they was it statistics?
Yes.
How did they learn statistics in the classroom?
So if they agreed to participate in the study,
Yeah.
so the statistics course at Carnegie Mellon, the traditional course, is 15 weeks with 4 class meetings a week, 3 lectures and 1 lab. So all the students were invited to participate. Of the subset who said, I'm in the study, then we took those and randomly assigned them to condition. We said, thank you, you're in the study, but you're the control condition, so you're going to take statistics the way you signed up for it. Go 15 weeks, 4 times a week. Or you've been selected to be in the experimental condition, so now you're not coming to the 4-time-a-week meeting. You come to class twice a week, and you're going to finish the course in 8 weeks, and you don't buy the textbook, you use this OLI thing.
How many signed up? What percentage of people you invited signed up for this?
Well, there were, I would say, let me see, I can give you the percentage. 47% of the students volunteer within, and we invited and we only left it open for 72 hours because we had more than the number of students we wanted to have in our sample. And to say you wanted to be in the study, you had to go into SurveyMonkey and fill out all this demographic, because I wanted to, even after we randomly assigned, I wanted to check the 2 samples to make sure that we weren't skewed by gender, class size, prior experience with statistic, SAT scores, all those things. And we also did do a pre-test and post-test in case there was any skewing in the sample. And we also did a follow-up study the following semester.
But wait, there's more.
And there's more. And we also did sampling during the semester of students in each of the conditions to find out how much time they were spending on statistics, because we wanted to make sure they weren't just cramming in that short, that they were actually taking the same amount of time. It was just compressed, but it wasn't. They were spending no more time than the students in the traditional course, which is interesting because they reported spending no more time outside of class than the students in the traditional course, but the students in the traditional course were in class twice as long, even during that sample week. So it was kind of interesting to me that they were actually spending a lot less time on statistics than the students in the traditional course. Yeah. Oh, I'm sorry. Go ahead.
Oh, I'm sorry.
Okay, no, my question was, where do you see in your model the student-to-student interaction as part of the learning experience? And then the other question is, do you guys work also with the hybrid models? And if you do, what's your experience? If you don't, what's your view?
Okay, so her question was, where in our model is the student-to-student experience, and do we work in the hybrid model as opposed to the pure online model? So I'm going to answer the second question first, because actually, while what we design is purely online, the way the courses are used almost completely is in hybrid mode. There are some institutions that are using these as purely online courses, but for the most part, the way these courses get used are in hybrid mode. And hybrid mode, for how I interpret it, you might have a different interpretation, is that the students are still meeting in a class with a faculty member face-to-face, and they're working in the OLI environment as the outside of class work. And then your first question was?
The student-to-student interaction.
Student-to-student interaction. Okay, yes. So when we started this project, which was in 2002, there wasn't as much sort of social connection stuff with media. So our architecture that we designed to support this was really individual student, individual computer. And so we haven't built in the taking advantage of the social connections of learning for a couple reasons. One of them is we didn't build the architecture that way. And the other reason is that's not Carnegie Mellon's course. You know, Carnegie Mellon's core strength is really AI, cognitive, human-computer interaction. But that doesn't mean that we're not interested in that. In fact, we had a research partner last year with Marlene Scardamelia and Carl Bereiter up at the University of Toronto who focuses on group knowledge building. And so rather than try and build it all ourselves when that's not our area of expertise, our intention is to partner with, and has been, to partner with people who that is their area of research and focus to do a combined study. And the other thing that we've done is for the current OLI courses is we use LTI, which is a standard which will allow you to plug an OLI course into another kind of learning management system. So rather than recreating all the discussion board and group stuff that other people are already creating, we just plug this in so that you can then create your activities around it. And then you had a question.
Oh, well, that was really kind of my question too. I mean, I was really struck by the communal aspect of teaching that you're emphasizing, bringing, you know, a community of people together with different skill sets. But the communal aspect of learning seems to not be part of this equation.
Yeah, so that's because, I mean, where we expect the communal aspect of learning happens is in that peer-to-peer interaction in the actual face-to-face classroom. And now that's shifting. We're going to be partnering with some other institutions whose area of research and focus is really on the other aspects of learning. Like, you know, we don't deal that much with identity development or senses of agency or stereotype thread or cues in the environment that tell you what your role is in that learning community. You know, that's not where we focused our research. And so what we're doing really soon is partnering with other institutions that is their area of research and looking at how do we build those kinds of experiments into these virtual environments. Especially now, I mean, one of the things that the MOOC phenomena is really bringing up is there's a lot of peer-to-peer work there. So looking at how do you design those peer-to-peer, I always hesitate to call MOOC environments peer-to-peer because they're not necessarily peers, they're just people who happen to be collected in the same environment with you. So anyway.
Let's talk a little bit about MOOCs, please. What do you think of all the recent set of controversies around them in terms of what happened at San Jose State and at other places that just as quickly as there was all this kind of adulation, there's also been equal amounts of pushback. So can you talk about that? And you're obviously separated from this, but you get all lumped in together. Right?
I do get all lumped in. And can we turn off the camera? No, we'll So no, I'll honestly say, in fact, I'm actually hosting a symposium for the Association for Computing Machinery, which is a big computer science organization for their online journal, where I wrote an opening piece about MOOCs, and then we've invited 12 other authors who have different perspectives about MOOCs to contribute their perspective, and then I get to write the closing, what did we learn from this experience. But some of the other authors are people that you mentioned in your opening. You know, Daphne's going to be writing a piece, and Anant's going to be writing a piece, and some skeptics, we found the skeptics, and they're writing pieces too. So my take on it is MOOCs have gotten, what I love about MOOCs is it's pushed the conversation to the fore. You know, I think that online and using technology to support higher education has been going on for decades. But most institutions, especially of certain tiers, and most faculty have been comfortable saying, well, I think I'll just sit this one out. And I think what MOOCs have done is really put pressure on folks to not have to is thinking, oh, maybe I can't sit this out. Maybe I need to really figure out what's going on and how we want to engage. And so what I really like about MOOCs is it has forced conversations among faculty and administrations at institutions that I think would not have felt pressed to have this conversation as the rest of the world is feeling the need to. Because most of our institutions, honestly, I mean, the other major conversation that is emerging in higher education is the cost attainment dual challenge. How do we get many, many, many more people with a greater diversity of background knowledge, relevant skills, future goals. How do we get them through a higher education experience without blowing the cost out of the roof? And places like Carnegie Mellon and Columbia, we're sort of privileged enough not to have to be squarely in the middle of that conversation, because there are plenty of people who are willing to afford the kinds of education that we can provide. But for many of our sister institutions in the public sector in particular, they're square in the middle of that conversation. And then at the same time, we've got this, what's the impact of technology on higher education? And I think those two conversations have come together, and people are thinking, oh, doing these massive open online courses will somehow solve the cost attainment challenge. And not the way they're currently being done. I think that they're actually driving us backwards a bit. We've learned a lot about how people learn. We've learned a lot about how to use technology effectively to support human learning. And the MOOCs are kind of taking the way we thought people learned, or the methods we used from 50 years ago, and accelerating them and disseminating them, instead of no, just think about what we know about how people learn and use that to inform your design. And the other thing about MOOCs that I'm hoping will change is the level of data they collect. So they get that massive amounts of data, but it's clickstream data. And so you have to use these pretty sophisticated data mining algorithms to try and figure out things that if you just design the activity so you could label the data a little bit, we could really learn a lot more, a lot faster.
So I hope you're talking to Anant and Daphne and Sebastian about all these.
I am.
Okay. Let's do one more question, and then she has the next meeting to get to. Any thoughts? Then let me ask you on cost. When people hear at academic institutions, when they hear about that this can save money, some people get very excited, and then some people worry that this means that, even though you can prove people are learning, not everybody learns enough, all of that, and jobs will be lost among faculty. Talk about that.
Okay, so this is a conversation I have with my provost all the time, because he said, if you're really talking about saving money, the biggest way to save money using these environments is exactly that fear that you started off with. We replace a bunch of faculty with computers, and then we save money. And I would say, well, a couple things. One of them is institutions are already doing that with the large lecture course. You just stuff more students in front of a single lecturer, and that's how you save money. And so what I'm saying is, if you're going to use that as your method for saving money, let's at least try and make that educational experience more effective. The other thing is, I don't actually think we're going to need fewer faculty or even a more de-skilled faculty. And here's why. I showed you that Instructor Dashboard. Okay, if you don't really know statistics, and you look at that dashboard and it tells you, here's where your students are struggling. To figure out, how do I take that knowledge of conceptually, where are my students struggling, and figure out how to help them get past that concept, I have to really get it myself. It actually takes, I believe, a much deeper level of expertise than giving the same lecture I've given on week three. So I actually think these environments will, in some ways, upskill in different ways the role of faculty. And what I think, so where's the cost saving then, Candace? You've just told me you need more expert people and about the same number of them. So where's the cost saving? Well, I think the cost saving is in a couple other places. One of them is that, if we truly can accelerate the learning, if we can get twice as many students through in a single semester, that's a cost savings right there. If you don't have students repeating, and it's not so much an issue, I don't think, for the Columbias of the world, but for a lot of institutions, for some really gatekeeper courses, the accepted rate of completion is 50%. So you have those students taking that class, taking it again. I mean, I have students that when they take the OLI statistics class, that's the third time they've tried statistics. And so if we can just get students to be successful the first time through, that's a huge cost savings. And I could go on. There's lots of ways that I see, and not to mention I'll give you my last little pitch, because this is why I think places like Columbia need to be involved in this. Because what I worry about is that what's happening through the emergence of technology and this cost containment and attainment challenge is we're going to get much more of a bifurcation in higher education. I mean, some would say we already have it. I think we have a stratification right now, but I see that stratification getting more and more bifurcated, where there'll be a handful of institutions, and Columbia will probably be one of them, that can still have a higher education that's something that remotely resembles what we think of as higher education. But then a ever smaller percentage of students will be able to have access to that kind of an education. And 98% of the students are going to be jammed into some kind of mass production higher education system that focuses largely on workforce training. And, you know, my first thing is, let's stop that from happening. But if we can't stop it from happening, what I would like to make sure is that 98% of people who get a higher education, that they get something that is reasonably close to what the privileged get, that have an opportunity to really think and expand their minds and get different perspectives. And I think the only way we're going to be able to do that is to use the technology effectively to help level the playing field so that people can effectively participate. Anyway,
On that happy,
that's my happy
thoughtful,
note.
hopeful note,
So-
let's thank Candace Thille.